this video, we will study about bias in artificial intelligence. Bias in a general sense is simply a preference for something. For example, we may have bias towards blue over red because of the color of your favorite shirt or car. Here we will study how bias can affect the decision making of an algorithm in AI. Please look at this picture and tell me which animal you can see, goat or sheep. Now look at this picture and tell me which animal you can see, goat or sheep. If we look at this picture carefully, we can see that the same picture can look different depending on how you look at it. For example, one person can look at the number 6 from one view and call it 6, but the same person can look at it from the other view and see it as number 9. This means two different persons can have different perspective about the same data. Here the image of number 6 is a data. This is another example of different perspective. A glass that is half full of water can be seen as half full by one person and half empty by another. It depends on how they look at the glass. All the previous examples showed that a perspective of a person is a way he or she look at the things. In AI, perspective is the way an algorithm decides to make decisions based on the data. When a person is said to be biased, it means that they have a preference or inclination towards a particular belief, opinion or perspective which influences their actions and decisions. Bias can be conscious or unconscious, and it can be based on a variety of factors such as personal experiences, cultural upbringing, social influences or individual beliefs. When we say that an algorithm is biased, we mean that it consistently gives results that are unfair to certain groups of people or types of data. There are many things that can cause bias in algorithms, such as using incomplete or biased data to train the algorithm, choosing parts of the algorithm that affect certain groups more than the others. For example, facial recognition algorithm that was trained on a data set that didn't show the full range of human diversity could be biased against some ethnic groups. In the same way, an algorithm used to evaluate job applications could be biased against women if it uses factors that have nothing to do with the job performance but have always been linked to professions that are mostly filled by men. Let us say we are making an algorithm to figure out if the next world champion in cricket will be an Asian team or not. We have the data shown in the image so that we could train the algorithm. So, what do you think will happen with the algorithm? In the data, we can see that most of the World Cups are won by non-Asian teams. This means that the algorithm will favor teams who are not Asian, and the next team which will be world champion may be a non-Asian team. This is how biasness works in an algorithm. There is another example where we want to develop an algorithm to find out who will be the next president of India, male or female. So, the output of the algorithm depends on how diversified the data is. If the data would be containing mostly males as shown in image, the algorithm will favor males in the output. If the data was containing mostly female images, result would have been different. Let us watch the video regarding algorithmic bias.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning.
Please refer to the below link for the complete video. Machine learning algorithms are created and trained by humans who may have conscious or unconscious biases. These biases can be reflected in the data used to train the algorithms, which can lead to biased outcomes. Human bias can be also introduced into the machine learning processes through the selection of data sets, the design of algorithms, and the interpretation of results. If a data set is incomplete or biased in some way, the algorithm may make incorrect or unfair predictions. Machine learning algorithms themselves can introduce bias through their design and operation. For example, an algorithm that uses facial recognition technology may be less accurate at recognizing the faces of people with darker skin tones because it was trained on data that is primarily composed of lighter skinned individuals. This bias can have serious consequences, such as leading to false accusations or preventing people from accessing services they need. Let us watch this video here.
During my first semester at MIT, I got computer vision software that was supposed to track my face. It didn't work until I put on this white mask. I'm thinking, all right, what's going on here? Is it the lighting conditions? Is it the angle at which I'm looking at the camera, or is there something more? That's when I started looking into issues of bias that can creep into technology.
For reference, we can view the video here. Algorithmic bias is when automated systems that make decisions like machine learning algorithms treat certain groups of people in a way that is unfair or unequal. These biases can happen for a number of reasons, such as using biased data, using bad algorithms, or interpreting the results in the wrong way. To stop algorithmic bias, it is important to carefully evaluate the data used to train algorithms. These algorithms are designed to clearly show that they can deal with possible biases, and algorithms should be tested regularly to make sure they are fair and accurate.